In this video, we're going to look at how to calculate the percent ionization of a weak acid. So the percent ionization is a measure of the strength of an acid. Kind of like Ka is a measure of how strong an acid is. Percent ionization is another way of measuring how strong an acid is. It's the ratio of the concentration of ionized acid to the initial concentration times 100. Put that another way, percent ionization is equal to the equilibrium concentration of hydronium divided by the initial concentration of the undissociated acid times 100. So something like a strong acid, a very strong acid like hydrochloric or nitric acid, would have a 100% ionization because they dissociate completely, but weak acids would have much less than that. So let's look at a problem to help us illustrate how to calculate percent ionization. Our problem says calculate the percent ionization of a 0.125 molar solution of nitrous acid, not nitric, but nitrous acid, that has a pH of 2.09. So you saw the formula for percent ionization. Pause the video and see if you can figure out how to calculate the percent ionization. Give it a try. Okay. So first thing I want to do is I'm going to write an equation showing the dissociation of nitrous acid in water, which of course will dissociate to give me hydronium and nitrite ion. Now, even though this may not be necessary, I always like to use an ice table to keep track of my concentrations. I know the initial concentration of my undissociated acid is 0.125, and hydronium and nitrite, those are approximately 0 initially. Now, here I can jump right down to the equilibrium concentration of hydronium because I know that the pH allows me to calculate the equilibrium concentration of hydronium, right? So to calculate the hydronium ion concentration at equilibrium, so that's what we're going for right here, it's equal to 10 raised to the negative pH. So I can take my pH and calculate the hydronium ion concentration at equilibrium, again, is 8.1 times 10 to the minus 3. So I can plug that in here. Now I have everything I need. I have my equilibrium concentration of hydronium and my initial concentration of nitrous acid. So again, the bigger this number here, the more hydronium that's produced, the more dissociation that you have, right? So the larger the concentration of hydronium relative to what you start with, the greater the percent dissociation and the stronger the acid. So the greater the percent dissociation, the stronger the acid, because it's a measure essentially of how much hydronium you produce relative to the initial concentration. So let's plug these numbers in and solve. So we plug in our hydronium and our initial concentration times 100, and we get 6.5%. So again, we can compare that to other acids to kind of get a measure of how strong or weak they are. I also want to mention one other thing. Here we use the pH to calculate the equilibrium concentration of hydronium, but we know there are lots of other ways to calculate this. In one type of problem, you may be given Ka, and you may have to set up an ice table and use the quadratic equation to calculate this. So this problem is a little more direct, but calculating hydronium equilibrium concentrations, there are other ways, so we want to be aware of that. So practice some more of these problems, get familiar with the concept and how to calculate percent ionization.